welcome you all in this session. As you are aware, in previous session we were working out couple of statements and we have checked many of them were true and many of them were false. So, we will continue the same exercise in this session as well. Let us look at once again statement number 11. A point estimate is often insufficient because it is either right or wrong, and the answer to this statement was true. Why it is true? Because point estimate either it may be right or it may be wrong, but if you give a range estimate, now there is a possibility of having that range estimate more right rather than more false. So, it is always good to have an interval estimate rather than point estimate for population parameter. In fact, I would like to discuss this statement once again, though we discussed in previous session. A sample mean is said to be an unbiased estimator of a population mean because no other estimator could extract from the sample additional information about the population mean, and we have said that this statement is right, but no, this is not a true statement, this is a false statement. Okay. So, this is the correction you are supposed to make. Let us move on to next one. The most frequently used estimator of sigma is S. So, what is this sigma? This is population standard deviation and S is sample standard deviation. So, most of the times we use sample standard deviation to estimate population standard deviation. So, this statement is true. Let us look at the next one. The standard error of the proportion is calculated as this. Is this the correct formula? Under root of p into 1 minus p divided by n. What do you think? Is this correct one? Yes, this is true, right. So, statement number 14 is true. Let us look at the next one, 15th number. The degree of freedom used in a t distribution estimation are equal to the sample size. Is it? Is it so? The degree of freedom generally we calculate by looking at sample size or something else. It is n minus 1, right. So, this statement is false. 15 number statement is a false one, right. Let us look at 16th number statement. The t distribution is less able to be approximated by a normal distribution as the sample size increases. What do you think? Does t distribution become normal distribution with decrease in sample size? Is this correct? No, it is not correct. In fact, the other way around is true. In fact, when the sample size increases, the t distribution approaches normality, right. So, this is false, right. Let us look at 17th number. The t distribution need not be used in estimating if you know the standard deviation of population. Is it? When do we use t distribution? In fact, we have talked about two conditions. T distribution is applicable when standard deviation of population is unknown as well as the sample size is 30 or less than 30, right. Otherwise, we will use z distribution. So, this statement is t distribution need not be used if you know standard deviation of population. Yes. So, this is true statement, right. Okay. Let us look at the next one. The sample median is always the best estimator of population median. In fact, we have talked about estimation of population mean from sample mean, we have seen estimation of population proportion through sample proportion as well, but there is nothing like sample median or sample sample median is estimator of population median, right. So, this is false statement, right. As the width of confidence interval increases, the confidence level associated with the interval also increases. Is this statement correct? Just think over it. As the width of confidence interval increases, the confidence level associated with the interval also increases. Yes, this statement is true, right. Again, let me tell you that confidence level is the probability within which the population parameter will fall within certain limits, and confidence interval is the range, or confidence interval is basically a range within which population parameter will fall, right. So, these two go hand in hand. So, when confidence level is more, confidence interval would be higher, right. But in real life situation, whenever you estimate something, whenever you go for let us say interval estimation, try to have interval estimation in such a way that its range should be small and confidence level should be very high. Okay. So, let us look at the next one. Estimating the standard error of mean of a finite population using an estimate of population standard deviation requires the use of the t distribution for calculating subsequent confidence interval. Though I did not talk much about this finite population parameter. So, for the time being we can skip this, but anyway this statement is false, right. Let us look at the next one. The percentages in t distribution table corresponds to the chance that the true population parameter will fall outside our confidence interval. What do we do in t distribution? Generally we look at the this is in fact alpha by 2, this is alpha by 2, is not it, and this whole area is 1 minus alpha, is not it. So, in t table we have seen the values of t are critical values of t at a particular degree of freedom, and that generally gives you the population parameter which is outside the confidence interval, right. So, this statement is true. In a normal distribution, 100% of the population lies within plus minus 3 standard deviation of the mean. Is this correct? We have seen properties of normal distribution. It is not 100% population, it is 99.7372, right, but it is not 100%. So, this statement is false. Let us look at the next one. When choosing an estimator of population parameter, one should consider sufficiency, clarity, efficiency, or all this. Sufficiency, clarity, efficiency, all of this, A and C but not B. So, the answer to this is A and C but not B. So, we want sufficiency and efficiency of an estimator, of sample estimator for estimating population parameter. Let us look at 24th, this good one. Suppose that 200 members of a group were asked whether they like a particular product. 50 said yes, 50 said yes, 150 said no. Assuming yes means a success, which of the following is correct? P bar 33 or 0.33, P bar 0.25, P 0.33 or P 0.25. So, the correct answer for this is B, right, which is 25%. So, P bar is 0.25, right. So, answer to this is B. Okay. Let us look at the next one. Assume that you take a sample and calculate sample mean as 100. You then calculate the upper limit of a 90% confidence interval for population mean. Its value is 112. What is the lower limit of this confidence interval? So, we know that the confidence interval is mean plus minus what? It is z into let us say it is z alpha by 2 sigma to the power divided by root n, right. So, since we know that this x bar is 100, so and its upper limit is 112, right. It means this value is 12, right, this entire value is 12. So, its upper limit is 112, 100 plus 12, 112. So, the 100 minus 12 would be 88. So, this is how you should be getting answer to this particular question. Let us look at 26th number question. After taking a sample and computing mean, a statistician says, I am 88% confident that the population mean is between 106 to 122. What does she really mean? Again, after taking a sample and computing sample mean, a statistician says, I am 88% confident that the population mean is between 106 to 122. What does she really mean? The probability is 0.88 that population mean is between this. Does it mean this A part, or does it mean B part? The probability is 0.88 that mean is equal to 114. The midpoint of the interval or C, 88% of the intervals calculated from samples of this size will contain population mean. Is this statement true for this particular given statement? All of these are E. So, we have said that it is the 88% of the intervals calculated from samples of this size will contain population mean. It is not necessary that this sample will contain population mean, or the next sample which you take up, it is not necessary that that would also be between population that would also be in interval, in between interval. So, it is the meaning is 88% of the times fractional 80% of the times the confidence interval forms will have the mean, right, and this is true for population mean as well as for population proportion, both the cases. Which of the following is a necessary condition for using t distribution? So, we have said that there are two conditions. First is the population standard deviation is unknown, and the second one is sample size is 30 or less than 30. So, let us look at this. N is small, is this necessary condition? S is known, but not standard deviation. S is standard deviation of sample is known, but not of population. The population is infinite. All of these A and B, but not C. What do you think? So, answer is A and B. Sample size is small, which is 30 or less than 30, and standard deviation of sample is known, not the population, right. So, correct answer to question number 27 is C, right. Let us look at the next one. Which of the following T distribution would be expected to have the most area in its tails? Generally, area in tails will be for a situation where mean is high and degrees of freedom is less. So, in this particular question, answer number or the part D is the answer to question number 28. Let us look at the next one. Which of the following is a difference between Z table and T tables? Let us look at these differences. The T table has values for only a few percentages. The T table measures the chance that the population parameter we are estimating will be in our confidence interval. We must specify the degrees of freedom with which we are dealing when using Z table. In fact, C part cannot be correct, right, because degrees of freedom goes with T table, right. So, you can just exclude C part from your answer list. All of this, no, all of this cannot be the answer because C is not the answer. So, this is also gone from the list of possible answers, right. So, you are left with A, B, A option, B option and E option. So, the T value has the T table has values for only few percentages. So, for 29th this is the answer, A is the correct answer, this is the answer, right, A part. Okay. Why in fact B part is not correct, right. Let us look at question number 30th. Suppose we are attempting to estimate a population variance, though we did not calculate any question on estimation of population variance from sample variance by using sample variance. It is incorrect to calculate sample variance as this, because the value would be, though we did not do any question on this, but in that case the value would be biased, right. So, it has to be n minus 1, right. Let us move on to next question. When considering samples with size greater than 30, we use normal table even if the population standard deviation is unknown. Why? Once again let me tell you, when do we use that, when do we use T table? When standard deviation of population is unknown and when sample size is 30 or less than 30. In all other situations we will use Z table. So, just remember these two conditions. So, when considering sample size greater than 30, we use normal table even if the population standard deviation is unknown. Why is this? The calculation of the degrees of freedom becomes difficult for large sample size. Is that the reason? No, that is not the reason. The number of percentages we need for the calculation of confidence interval exceeds the number contained in T table. C part, it is difficult to calculate mean for large sample, none of these, and E option is A and C, but not B. So, the answer to this is none of these. Okay. So, let us move on to next question. Assume that from a population with sample size 50, a sample of size 15 is drawn. So, how much percentage is this? approximately 30%, right. Sample size is 30% of the population size. So, assume that from a population mean with n is equal to 50, a sample of size 15 is drawn. Standard deviation of population is known, which is 36, and standard deviation of sample for the standard deviation for the sample is 49. Sample mean for the sample is calculated as this. So, when we took a sample size of 15 from a population of 50, its variance was this, standard variance of sample is this, and sample mean is this. Which of the following should be used for calculating a 95% confidence interval for mu? Which of the following should be used for calculating a 95% confidence interval for mu? So, students t distribution, normal distribution, finite population multiplier, A and C, but not B, and B and C but not A. Okay. So, the answer for this is E. So, B and C but not A. So, B and C is normal distribution. Why normal distribution? Because you have been given what? Standard deviation of the population, is not it? And what is that value? It is 6, because variance is 36. So, standard deviation would be 6. So, we will be using normal distribution. Finite population multiplier is needed, because this sample size is approximately 30% of population. So, generally we use finite population multiplier if sample size is 10% or more than 10% of the population, right. So, the answer to question number 32nd is E. Okay. Let us move on to next one. We can use the normal distribution to represent the sampling distribution of the population when. When do we use normal distribution? Sample size more than 10, less than 50, more than 5, none of these. We can use normal distribution to represent sampling distribution of the population when. In fact, these are just a few statements written over here to confuse you. None of these is the answer, right. Let us look at next one. If a statistic underestimates a population parameter as such as it overestimates it, we conclude, or we would call it consistent, sufficient, efficient. If a statistic underestimates population parameter as much as it overestimates it, so it is none of these, is not it? The answer is none of these. In fact, if if a statistics underestimate a population parameter as much as it is overestimates, then you would get the correct population parameter. That is the property of getting correct population parameter. Let us look at 35th one. If population proportion information is unknown, the standard error of the proportion can be estimated by the formula. If population proportion information is unknown, so in situations like this, what we take? We take it as 0.5, right. The standard error of proportion can be estimated by this formula, and the answer is D, right. So, we will assume P is equal to 0.5 and Q would be 1 minus 0.5, right, 0.5, right. Let us look at next question. the average height of 25 students in Mr. Stanton's 10th grade math class is known to be 66 inches. So, average height is given. In constructing a 95% confidence interval for the average height of all 10th grade, we would be using what? What we would use? The normal distribution with 24 degrees of freedom. You see, normal distribution is our Z distribution. So, this cannot be correct, because degrees of freedom goes with T distribution, right. T distribution with 24 degrees of freedom. So, what is the sample size? 25. So, n minus 1 is 24. So, this answer is correct. In fact, out of all these 4 options, you can easily identify right answer, because when n is 25, you will have to have 24 degrees of freedom. So, you can easily skip these 2 options from your answer list. Only the option left would be A and B. A cannot be, because degrees of freedom is associated with T distribution. So, only B is the right answer, right. So, this is how you can answer some of the questions. A certain normally distributed population has a known standard deviation of 1. So, there is a normally distributed population, standard deviation is 1, mean is not given, right. What is the total width of a 95% confidence interval for the population mean? 1.96, 0.98, 3.92, nothing. So, it cannot be determined from this information. Why? Because we have not been given mean, right. Okay. So, what is the total width of the of 95% confidence interval? Because we have not been given population mean. So, either you will have to have population mean, or you will have to have sample mean, right. Then only you can have confidence interval. Let us look at this slide, the last one. A single number used to estimate an unknown population parameter is a dash estimate. A single number used to estimate an unknown population parameter is point estimate, is not it. A range of values used to estimate a range of values, right, not a single number. A range of values used to estimate an unknown population parameter is interval estimate, is not it. Let us look at the next one. Once we know something about a sample, the number of values in which sample, the number of values in the sample we can specify freely is called degrees of freedom, is not it. Next one, the family of probability distribution used when population standard deviation is unknown, the sample size is small, and the values approximated the normal is called what? Students T distribution, or just T distribution. A family of probability distribution used when the population standard deviation is unknown. So, we use sample standard deviation, the sample size is small and the values approximate the normal is T distribution, right. Let us look at the next one. When we give an interval estimate of a population parameter, we show how sure we are that the interval contains the actual population parameter by setting a what? confidence level, is not it, confidence level. Okay. The upper confidence limit and the lower confidence limit are the same dash from dash, are the same distance from the mean, right. Theoretically dash distribution is the correct distribution to use in constructing confidence interval to estimate a population proportion. So, this is binomial. Let us look at the last question. In the absence of additional information, a value of dash should be used for p when determining a sample size for estimating a population proportion. 0.5, 0.5 should be used. So, in today's session we have worked out couple of examples, and I hope that with these couple of questions the fundamentals of estimation would have more known to you. We will have next session on hypothesis testing. Thank you very much.